Assalamualaikum warahmatullahi wabarakatuh. My name is Siti NURNAJIHAH binti ZULKIFLI and my metric number is 2010911054. Okay, today I will explain about our mini project which is design and evaluation of hybrid wind PV renewable energy system across the region of Lundu, Sarawak. As the global demand for energy continues to rise, the need for sustainable and eco-friendly solution has become paramount. Renewable energy sources like solar, wind and hydropower offer clean alternative to traditional fossil fuels. So, our renewable energy installation services are designed to provide home and business with efficient, reliable and environmentally responsible energy solution. Next, there are 4 types of renewable energy solution. First is solar power system, second is wind turbine, third is hydropower solution, and lastly is battery storage system. So, we offer a range of renewable energy installation that can be customized to meet your specific needs. So, why we choose renewable energy is because switching to renewable energy offers numerous advantages for business and homeowners alike. Business and homeowners can be benefit from the switch to renewable energy in many ways such as environmental impact, cost efficiency, and energy independence. So, for environmental impact, we can reduce carbon emissions and aid in the fight against climate change. For cost efficiency, we can lower energy bills through renewable and long-term solutions. And lastly is energy independence. We can reduce the reliance on traditional power grids and fossil fuel.
My name is SYAFIQAH MASSUWAN and I will continue the presentation on the system description. So in this project, we choose the hybrid floating solar and offshore wind turbine at the coastal area of Lundu. And so this figure shows the hybrid system overview where the main component of the system are wind turbine, PV array, the battery bank and the system converter. As we go deep into the design consideration, for wind turbine, we use horizontal axis wind turbine because higher efficiency and also can capture steady and unidirectional wind. The wind turbine is located at the offshore and the head of pole is very tall so that they can harness stronger and more consistent coastal wind. Next, for the floating PV system, it utilizes available water surface and also reduce land usage and that can improve the efficiency of PV cell as the cooling effect of the water. And next, for the battery bank system, it stores excess energy generated by the hybrid system to be used in case of days of autonomy where low wind speed or reduced solar radiation. The design of battery system depends on the configuration and the capacity needed. And lastly, the DC to AC inverter is used to convert DC power generated into AC power for compatibility with the end user household. Okay, so Lundu district located in Sarawak is selected and the table shows the latitude and longitude of the selected coastal area near the Longhouse village. And based on the case study, the mean energy consumption is estimated to be 4.35 kWh per day. The highest load demand occurs at 8 p.m. with 490 watt power consumption and the lowest load demand is at 100 watt. We can see that the energy usage at night increases as it involves lighting, dinner preparation and social activity among the family members.
Hi, Assalamualaikum. My name is ARIFAH binti MOHMED RAFID. My matrix number is 21109250. Today I will present about the methodology of the mini project. I will start with the flowchart first. This flowchart explains the process of planning and testing a hybrid energy system. It begins by determining a good location for the hybrid system and gathering wind and solar statistics for the area. If the wind speed exceeds the minimum requirement for wind turbine operations, the system is developed and simulated with HOME software. The next step is to evaluate the system energy output and environmental impact. If the design fits the requirement, the procedure considers the system practical, otherwise the system is declared unfeasible and the process cycle back. Next, let me explain the mathematical modeling behind the total power generation of a PV wind hybrid system. This model combines the power output from both solar panel and wind turbines, offering an efficient way to meet energy demands with a single capital investment. The total power generated by the system PT is represented at Formula 1. The power generated by the wind turbines PW is calculated using Formula 2. Now moving to the solar PV modules, the power generated P array is calculated using Formula 3 and lastly for the overall efficiency it is calculated using Formula 4. This formula links the system performance and the availability availability of solar energy, providing a comprehensive view of its energy conversion efficiency. In summary, these equations work together to model and predict the energy generation potential of the PV wind hybrid system, helping optimize its design and performance.
Hi, my name is UTHAYAKUMAR, SATYASEELAN, metric number 211-090989. So now I will be discussing on the simulation modeling and also perform an analysis and give a discussion on the simulation output that we have done for this project. So first of all, for the simulation modeling in this project, we have used two main source of component, which is the wind turbine as well as the PV solar. For the wind turbine, we use Zen M21, and for the PV solar, we use the standard PV solar panels that are available in the Homer simulation software. So for the Homer simulation software, most of the setting values are already preset values, except we have tuned certain values according to our research findings. So for the wind turbine, we use rated power capacity of 100 kilowatts, a height of 31.8 meter, and also a lifetime predicted around 20 years. And followed by the PV solar, it up to 1 kilowatts and also lifetime of 25 years. And this is based on the research finding, and we have implemented this model into our simulation model. And rest of the values are the preset values that provided by the Homer software.
Okay, so now we will go to the result discussion part. I will discuss on the resources profile of the Lundu. Okay, for the wind resources, we can see that the pattern of wind speed data fluctuates and non-uniform. But still, most of the time, typically during nighttime hours, the wind speed is higher than the cut-in wind speed, which are 3 meters per second. This shows that the stable wind speed in the coastal region of Lundu make it feasible for the wind energy generation. Okay, so for the solar sources, we can see that the pattern of irradiant data follow the peak sun hour curve, and the solar radiation is generally the highest from 8 am to 1 pm. This allows approximately 5 hours of PV panels to generate maximum energy during the daylight hours. This shows that the consistent daytime of solar energy output contributes significantly to the charging of battery bank, so that it makes it feasible for the PV solar energy generation. Okay, for an up-to-date insight, the mean annual data for both resources are obtained from the Global Wind Atlas and Global Solar Atlas. We can see that the annual mean wind speed exceeds the threshold, which is 3 meters per second, and the annual GHI exceeds 1000 kilowatt hour per meter square. Therefore, we can conclude that the hybrid system is feasible to be implemented.
Next, for the simulation outcome and analysis, we perform 5 analyses for this: cost summary, cash flow analysis, electrical energy production, gas emission rate, and also the wind turbine power generation curve. Starting with the cost summary, so this is the cost summary. So this is the cost summary graph. So there are 3: battery, PV solar, and also the system converter. So followed by the analysis. For the initial investment, hybrid and renewable energy system incurs a significant initial cost, approximately to $20,000 in the first year, primarily due to the installation of solar panels, wind turbine, and battery storage, which is as expected. And it follows with a negative cash flow, and the first few years shows a moderate negative cash flow due to operational and also maintenance expenses, and profitability at the end of the simulation. Let's break down the cost summary. So from here we can analyze and perform analysis. We can understand that the major expenses is leads from the battery storage unit, which is causing up to $18,000 approximately, and also very minimal cost requirement compared to this, which is the solar panels and also the system converters. So from here overall we can say that the simulation indicated that despite high initial investments and early operational expenses, the system financially viable in the medium term and highly profitable in the long run. Next, let's talk about the cash flow analysis. So this is the cash flow analysis graph that was obtained through the Homer software when running the simulation. So from here we can see that overview, financial performance. The cash flow analysis illustrated that financial performance of the hybrid renewable energy system over a 25-year life cycle. So initially there's a negative cash flow followed by midterm stability. The cash flow remains stable with no major expenses, then followed by a replacement cost on the year 15. Otherwise it's really performing very well, and followed by the electrical energy production, which is the most important analysis that has to be performed for this simulation model. We can see that there's a curve or there's a pattern of energy production across the 12 months. So from here we can see the monthly electrical production is derived from the solar photovoltaic panels and the wind turbine, which is the primary source for the system. So we can say there are a lot of factors. One of the factors is seasonal variation. We can say that the winter peaks, summer, spring, autumn, all this plays a significant role in the energy production for using the wind turbine, also the solar panels. So we can say annual production summary. Annual production of wind turbine produce around 86.6% of the total energy production of this system, and PV solar contributes about 13.4%, and which is also significantly exceeding the annual energy consumption. So in this case we can say the system is very well built, is more than needed for the energy consumption in that area. Next, the gas emission rate. We can see here from here it's already zero. We can say that this system is very well designed, and this result is obtained from the HOMO software, and this is the very minimal that we could get, and this is very optimum for us to pursue the sustainable development goal, as well as maintaining net zero emission for carbon dioxide, carbon monoxide, nitrogen oxides, and all these hazardous gases. Next, followed by the wind turbine power generation curve. From here we can see that wind turbine curve shows that power output increases as wind speed rises. So as a conclusion, we have successfully designed and evaluated the hybrid renewable energy system for rural community in Lundu, Sarawak. Integration of technologies, detailed analysis, which is using the HOMO software for thorough modeling of energy performance, cost effectiveness, and also the economical and also environmental benefits. We have performed a consistent energy generation followed by 100% renewable fraction, long-term viability, and also we have addressed the energy challenges in this project. So this is from us. Thank you.